All right, so I'm going to be going over problem 2894, divisible and non-divisible sums difference. It's an easy problem. So we are given positive integers n and m. These are going to be a number and a number. They're both going to be positive. We have to define two integers, num1 and num2, as follows. Num1 is the sum of integers in the range from 1 to n that are not divisible by m. And num2 is the sum of all integers in the range 1 to n that are divisible by m. So we return the integer num1 minus num2. So we have a couple steps here. One of them is we need to figure out what num1 and num2 are. Number two is we need to return the integer num1 minus num2. So you can see for the first example, n equals 10. So from 1 to 10, we're going to test 1 divided by m, 2 divided by m, 3 divided by m, 4 divided by m, all the way to 10. And for the ones that are divided by m and are not perfectly divisible by m, we're going to just add them to num1. We're going to do the same thing for the divisible ones. And so we could either separate this task and do this separate from this, or we could do it all in the same for loop. We're going to see an example of both. So I'm going to give you 3 solutions for this problem here. And then just to look at the constraints, both n and m are going to be anywhere from 1 to 1,000. So the first solution I'm going to show you is just a brute force solution. And the first brute force solution I'm going to show you is, I'm going to write out the pseudocode for you first. But what we're going to do is we are going to find out, and this is less efficient because this is going to be O of n space and also O of n time. And so what we're going to do is we're going to create our sequence. Let's go ahead and say create the sequence from 1 to n. We are going to create our num1 variable using built-in methods. We're going to create our num2 variable using built-in methods. And then we are going to return num1 minus num2. I believe it was num1 minus num2, yes. So we could just go ahead and do that now. And the way we're going to create the sequence is we're just going to say let sequence equals empty array for let I equals 1. We're going to start with 1, go all the way to n. Well, I is less than or equal to n inclusive I plus plus. And for each number up until n, we're just going to say sequence dot push I. Now if I go ahead and console out our sequence, you can see console.log sequence push. This is 3 mathematical. Num1 is not defined, so let me just comment that out quickly. Boom. So we have our sequence. In the first one, where n is 10, then we have n is 5 and n is 5. So we have 1 through 10, 1 through 5, 1 through 5 in our 3 examples. So now that we have our sequence, and what I'm going to do is I'm just going to move this code over to this file. And okay, so we're going to create our num1 now. So we're going to do num1 equals, what we want to do is we want to take our sequence. So we have our sequence here. to do is we just want to filter over the sequence, starting with 1, then 2, then 3, then 4, then 5, then 6, and for each one. So for 1, we're going to do modulus m and see if it's perfectly divisible. If 1 modulus m, which in the first example is 3, is not going to be 0, so it's not perfectly divisible, we are not going to add that one. 2, same thing, we're not going to add that one. 3 is divisible by 3, so when we do 3 modulus m, we're going to get 0 perfectly, and we're going to add this one to num1. And so let me just see. Num1 is not divisible. So actually it's the other way around. We're going to add 1, we're going to add 2, we're going to add 4, 5, 7, 8, and 10. For num2, the ones that are divisible, we're going to add 3, 6, and 9. So we're going to filter. And for each number, we're going to say if num modulus m equals 0, or should I say it does not equal 0 because we're building up num1 right now. Num1 is not divisible by 0, or not divisible by m. So this is going to return each element that returns true for this case. And then once we have the array, we're going to do reduce. We're going to take our accumulator, and we're just going to do accumulator plus current starting at 0. So if you want to learn more about these built-in methods here, feel free to just do a quick Google search. You'll understand exactly what this is doing. And then we're going to do the same thing for num2. The only difference is we're going to return if it's equal, if it is perfectly divisible, and then we're going to print that out. So we should be good now. Let me go ahead and test this here. We're getting 19, 15, and negative 15. So if we see here, 19, 15, and negative 15. So that code is working right there. Feel free to take a screenshot of that, walk through the code line by line, actually understand what everything is doing here. And then I'm going to show you a better solution, because this is O of n space, because we're actually creating a new array, and for every number 1 to n, we're creating an element to put inside of this array. So this would be O of n space, O of n time, because not only are we iterating from 1 to n, but this filter is also O of n, this reduce is also O of n, this is O of n, and this is O of n. So technically it would be 5n, but since we've removed the constants, we just set it to n. So now we're looking at brute force 2. This one, we're not going to create any extra space. So in this one, we're just going to create 2 variables for num1 and num2. We're going to iterate from 1 to n, and then we're going to do a check. If I divided by m equals 0, if it does, if it is perfectly divisible, then add to num2, else add to num1. So first thing we're going to do here is just create num1, set it to 0, create num2, set it to 0, and I like this brute force solution a lot better. It's just simpler and it's more efficient, at least space-wise. Same thing, we're going to set I to 1. We're going to go while I is less than or equal to n, because we do need to include n, and then we'll increment I. Okay, we're going to check if I modulus m equals 0. Then we're just going to do num2 plus equals I, else If it's not divisible, num1 plus equals I. And then we should just be able to return num1 minus num2. And we should be good to go. 2, 19, 15, negative 15. So we're good to go. Last but not least, we have a mathematical solution. I'm going to expect y'all to break this one down the best you can. I'm going to go ahead and type these formulas out. These formulas are not intuitive, and you're not going to understand it unless you have the fundamental and foundational mathematical knowledge. So if you would like to, feel free to type it into ChatGPT or Google, do further research. But essentially what I'm doing here is calculate the sum of integers from 1 to n that are divisible by m. So this formula is going to represent num2. We're going to calculate the total sum of integers from 1 to n. We're going to calculate the sum of integers from 1 to n that are not divisible by m. And we're going to do this because this line of code is going to figure out nums2. This one is going to figure out the total sum from 1 to n. And then we're going to subtract num2. So this calculation from this calculation, which is going to give us num1. And then we just return the difference. So return num1 minus num2. That's going to be our output. So this is the formula for num2. I believe we could just do constants. We're not going to change it. And it's going to be m times math.floor n divided by m times math.floor n divided by m plus 1 divided by 2. That's going to give us the sum of the sequence from 1 to n of the numbers that are divisible by m. Then we're going to get the total. So we're going to say total sum equals n times n plus 1 divided by 2. That's simple enough there. And then we're going to find out our num1 by just doing total sum minus num2. And that's that right there. This is going to be the most efficient one here. Let's just test it out. And yes, we're getting 19, 15, negative 15. This one's the most efficient because these are formulas, and the formulas are going to end up being O of 1. The only space we're creating is also 1, 2, 3. So we're creating 3 variables. That's a constant. So O of 1 space. We're not doing any iteration. This is just one calculation, one calculation, one calculation, one calculation. So for total operations, which is still going to be O of 1. So this is O of 1 time and O of 1 space. If you have any questions or comments, feel free to leave them in the comments below, and I will get back to you.